Hi guys, this is Maritza Wattimena speaking, and right now I'm going to be presenting my Smart PLS output from building the model, importing the data, and analyzing outer and inner model. So let's start with importing the data from Excel. This is the Smart PLS screen, and we can click it right here, the new project, and we can name it whatever we want. There you go, and double click to import the data. Make sure to make it in the CSV format, because if it's still in the Excel format, it will not appear right here. So we click this one, this is data, okay. Okay, right now we will be able to see the mean, median, standard deviation, skewness, and other data. And in the indicator correlations, we will be able to see the correlations between the indicators. Okay, right now let's click this part, ALP stat. This is the drawing pad where we will put all of the indicators. So we start with this one, it's extroversion.
Right here, this is conscientiousness. This one is financial risk tolerance. Financial risk tolerance. Okay, and lastly, it's financial literacy.
Okay, we can name it to make it more easier. Extroversion.
And then this one is financial risk tolerance. Financial literacy.
Okay, after this, we will have to connect it all. We just click this part, connect from the independent variable to the mediator and then to the dependent. This one too, okay? And now the direct relationship from the extroversion to financial literacy and this part too. Okay, after this, we will analyze the outer model using the PLS algorithm. The step is to click this part, calculate PLS algorithm. Okay, this part, yes. Now just start calculation. Okay, first of all, we will start with clicking this part, outer loadings. Here we can see that some of it are red. So the good one is to be higher than 0.7. So we will just delete several data from here, C1, FL4, and okay, so I'll go back to this part, select, so this one, delete it, FL4. Okay, right now we have to calculate that again. And then start. Check again in the outer loadings, see if it's all green. Yes, it's all green, therefore it has fulfilled the benchmark. Right now, let's conduct the reliability analysis. Go to this part, construct reliability and validity. Here we can see several measurements, Grunberg's alpha, rho A, and composite reliability. If it's all green, and the good one, the reliable data, is to be higher than 0.7, and it's all higher than 0.7. The value of rho A should be between the value of Grunberg's alpha and composite reliability. So if it's all green, then it means our indicators are reliable. Okay, right now we have to see this part, AVE. It is to see the convergent validity. AVE value should be at least 0.5. And if we can see it right here, it is all more than 0.5. Therefore, the convergent validity prerequisites are fulfilled. Okay, next we will see the discriminant validity right here. And it is to make sure that the indicator of variables is different from indicator of other variables. There are several methods that we can see right here, but we will only use the HTMT. Okay, and we can see here the HTMT should be less than 0.9. If it's all green, then it is all less than 0.9. Therefore, the indicators representing a variable are different from other indicators of other variables. Now, all of the outer model are done, and let's hop on to the inner model. We can see it from the PLS algorithm, and then we check this part, collinearity statistic, VIF. And then we pick this one, inner VIF. Okay, so the rule is the VIF is to be less than 5. So from this data, we can conclude that there is no multicollinearity. Next, we will see the direct and indirect effect. We can see it from the bootstrapping result. How to do it is go back to this part and then calculate, and then choose bootstrapping. Okay, we will use two-tailed and significance level is 0.05, and then start calculation. Okay, so we can see here the p-value. Yes, okay, so the relationship is significant if the p-value is less than 0.05. And right now we will summarize together using the diagram that I have provided. So we can see it, the extroversion, the relationship between extraversion and financial risk tolerance is not significant from this data. And financial risk tolerance to financial literacy is significant but negative from this data too. And the direct effect from the direct relationship from the extraversion to financial literacy is not significant. On the other hand, conscientiousness to financial risk tolerance, it is not significant, and the direct relationship from conscientiousness to financial literacy, it is significant and positive. Right now, we want to check whether the financial risk tolerance can mediate the relationship between extraversion and financial literacy. And we also want to check whether financial risk tolerance can mediate the relationship between conscientiousness and financial literacy. Using Smart PLS, we do not need to conduct Sobel test. We can see it from the specific and indirect effect right here. Okay, so if we see it here, financial risk tolerance cannot mediate the relationship between conscientiousness and financial literacy, as well as extraversion and financial literacy, as we can see from the p-value right here. The direct and indirect effect from extraversion to financial literacy, it is not significant, therefore it has no mediation. And the direct effect from conscientiousness to financial literacy is significant, however, the indirect effect is not significant, therefore it also has no mediation. Next up, we have to see the R-square. It should be right here, PLS algorithm, and then click the R-square. R-square represents the proportion of dependent variable that can be explained by the independent variables. Right now, we can see it here that financial literacy can be explained by conscientiousness and extraversion by 32.5%, and financial risk tolerance can be explained by conscientiousness and extraversion by 1.7%. The R-square adjusted is the proportion of the dependent variables that can be explained by the independent variables that are significant only. After seeing R-square, and then now we should hop on to F-square. It represents the effect size. So, conscientiousness towards financial literacy, it has medium effect. Extraversion has no effect at all. Financial risk tolerance has small effect. On contrary, financial risk tolerance towards financial risk tolerance, conscientiousness have no effect, as well as extraversion. Okay, lastly, we will see the Q-square. We will be able to see it if we go back to this part, and then we'll calculate just this one, blindfold. Okay, omission distance is 7, meaning 7 here is we try to remove the data in every 7th position. After that, we will start calculation. So we will see this part only. From this data, we can conclude that financial literacy and financial risk tolerance have small predictive relevance. To conclude, we will go back to this part, bootstrapping, and then click specific indirect effect. Okay, so from this data, we can conclude that extraversion to financial risk tolerance, it has no effect. And then financial risk tolerance to financial literacy, it has an effect, it's significant and negative, but it is weak. The direct relationship, extraversion to financial literacy, it has no effect. For conscientiousness to financial risk tolerance, it is not significant, so it has no effect. However, the direct relationship from conscientiousness to financial literacy, it is significant and positive. The effect is moderate effect. And then, therefore, the financial risk tolerance cannot mediate the relationship between extraversion and financial literacy. The direct and indirect effect from extraversion to financial literacy is not significant. Therefore, it has no mediation. Financial risk tolerance also cannot mediate between the relationship between conscientiousness to financial literacy. The direct effect from conscientiousness to financial literacy is significant. However, the indirect effect is not significant. Therefore, we can say that it also has no mediation. I think that's all from me. Thank you for watching.